Assalamu alaikum. Okay, we will continue the lecture of second law of thermodynamic or efficiency of engine and others application. Okay, another example. We have to consider two engines. في عنا محركين اثنين. The details of which are given in the following diagram for both engines. إذا عندنا hot at 400 Kelvin يعطي heat at 1000 joule and we have the work at 2000 joule and heat at cold reservoir 300 Kelvin. The other one is we have at hot reservoir 400 Kelvin and heat 1000 joule and the work 300 joule. Here, then the difference is the work in both engine and the heat in cold reservoir 300 Kelvin. Okay, calculate the heat flow to the cold reservoir and the change in entropy of the heat reservoir, cold reservoir and engine. Which engine violates the second law? What is the efficiency of the working engine? Okay, we start by the first law of thermodynamic. That means delta U equal Q minus the work. And you know why is the minus the work. Engine, the cyclic process, delta U equals 0. So in this case, Q equal the work. طيب الwork بيساوي QH minus QC. هذا يؤدي إلى أنه QC تساوي QH minus the work. Then engine 1 QC at cold reservoir 1000 ناقص 200 بيساوي 800 جول and engine 2 QC بيساوي 1000 ناقص 300 بيساوي 700 جول. Okay, what is the entropy? The entropy which equal minus QH over TH زائد QC over TC. Engine 1, the entropy delta S equal minus 2.5 زائد 2.7 جول Kelvin inverse وتساوي 0.2 جول Kelvin inverse and this is greater than 0. Engine 2, the entropy minus 2.5 زائد 2.3 جول Kelvin inverse بتساوي minus 0.2 جول Kelvin inverse and this is less than 0. So this one second law not validated. Then which one? Engine 1 because the entropy it's always positive أكبر أو تساوي from 0. So engine 1 is the working engine. What is the efficiency? The efficiency in this case equal the work out على the work input ضرب 100%. So we substitute work out 200 على energy input 1000 ضرب 100%. So the efficiency which equal 20%. Okay. Example 9. A hybrid petrol engine. What do you mean by hybrid? Hybrid is mixed. Then a hybrid petrol engine car has a higher efficiency than the petrol only car because it recovers some of the energy that would normally to be lost as heat to the surrounding environment during braking. تعرفوا هسه في الوقت الحاضر في بعض السيارات اللي هي بتكون مدموجة ما بين البنزين وبتكون هايبر اللي هي بين البنزين وميكانيكال power or some if you make a break or some that we have lost energy هاي lost energy تتحول لميكانيك. Okay. إذن A, if the efficiency of the typical petrol in the car engine is 20%, what efficiency could be achieved if the amount of heat lost during braking is half? B, is it possible to recover all the energy lost as heat during braking and convert it to mechanical energy? Explain your answer. Okay. Okay, in this solution, we have to start by the efficiency. Efficiency equal 1 minus QC over QH. In second law of thermodynamic, 100% of heat cannot be transformed into mechanical energy. This means that the efficiency, it will be less than efficiency تساوي 1 minus QC على QH تساوي 0.2. هذا يؤدي إلى أنه QC على QH تساوي 0.8. So reduced heat lost by half as in the question. So QC على QH راح تساوي 0.4. This means the efficiency equal 0.6. Would require QC magnitude equal 0. This would be a violation of the second law. Then the efficiency equal 1 minus QC على QH, it's less than 1. هذا يؤدي إلى أنه QC على QH greater than 0 and QC أكبر من 0. Another types of engine is Stirling heat engine. It is simple, practical heat engine using a gas as working substance. It's more practical than Carnot. Though its efficiency is pretty close to the Carnot maximum efficiency. The Stirling engine contains a fixed amount of gas. Then we have fixed amount of gas, which is transferred back and forth between a cold and hot end of a long cylinder. Okay, so the displacer piston, we have here the piston. The displacer piston move the gas between the two ends and the power piston. Change the internal volume as the gas expands and contracts or compression. So the gases used inside the steering engine never leave the engine. There are no exhaust valves that vent high pressure gases as in gasoline or diesel engine. إذا بنعرف بالجازولين أو الديزل engine في عندنا exhaust. There is some discharge of energy, but the steering engine never leave the engine. There are no exhaust valves that vent high pressure gases لتفريغ ايش؟ الهاي pressure gases. So and there are no explosions taking place. Because of this, steering engine are very quiet. إذا ما في نتيجة الإكزوست تسمعوا هاي explosions taking place اللي بتحدث في الانجن. So the steering cycle uses an external heat source. إذا هون بيستخدم an external heat source which could be anything from gasoline to solar energy to the heat produced by decaying plants. Today, steering engines are used in some very specialized applications like in submarine or auxiliary power generators, where quiet operation is important. إذا هاي السترنج heat engine. إذا another type of engine or another application for engine in our life. Okay. What is the efficiency if we calculate the efficiency of a stirring engine? In the stirring heat engine, a working substance is an ideal monoatomic gas at initial volume V1 and temperature T1, takes in heat at constant volume until its temperature is T2. Okay, constant volume until temperature is T2, and then expands isothermally until its volume is V2. It gives out, in this case, heat at constant volume until its temperature is again to T1. Then until the temperature goes to T1 and volume 2. It gives out, in this case, هسه راح تخرج الهيت constant volume until its temperature is again T1, and then return to initial state by isothermal compression or contraction. So the efficiency compared to current engine operating between the same two temperatures equal. If now from 1 to 2 Q12 تساوي CV في T2 minus T1 وتساوي 3 2 NR T2 minus T1, and this is equal 0, and the work from 1 to 2, of course, because it's constant volume, which equal 0. Now from 2 إلى 3 Q2 إلى 3 الانتجرال from V1 to V2 PdV وتساوي nRT2 في الانتجرال from V1 to V2 dV by V, and this is, it will be greater than 0, and in this case Q2 إلى 3 تساوي minus work 2 3. طيب now also من 3 إلى 4 Q3 على 4 تساوي CV في T1 minus T2, and this is will be less than 0, and the work, because constant volume, من 3 إلى 4 أوكي راح يساوي 0. أما من 4 إلى 1 فQ من 4 إلى 1 تساوي الانتجرال from V2 ل V1 وتساوي is will be nRT1 بلن V1 على V2, and this is less than 0, and also the Q in this case من 4 إلى 1 تساوي minus الورك من 4 إلى 1. إذا نحسب الإفشنسي أن 1 على الإفشنسي تساوي QH على QH minus QC. QH في هاي الحالة تساوي Q1 2 زائد Q2 3 مقسومة على Q2 3 ناقص Q4 على ناقص Q4 1 يعني QH ناقص QC, and this is will be أكبر من 1 على الإفشنسي max. Okay. Another application of second law of thermodynamic is the Otto cycle. In next lecture, we will discuss the Otto cycle, which work in cars and other application. Okay, so I will end this lecture at this point, and thank you for your attention.